All right, Jason.
Alright, my name is Jason Cyrus, and the name of my senior project is Delta Animals, which was a study on EEG perception, analysis, and connection. So a little bit about me. I've always been into building things, so senior projects was kind of just a natural step for me. I've been programming for 5+ years. I played varsity tennis here, and I'm actually a junior in senior projects. So this is one of the first robots I ever built. It was like a little, you would follow a cup and shoot at the ball. There's another robot I built. It would navigate a maze. You can kind of see it failing because it's bumping into the blocks. But anyway, I also didn't do TSA. And me and my team have been state runner-up for 2 years in a row, and we competed at nationals last year, and we're going to compete again this year. We also did TSA this year. I did a robotics competition where I got second in state with our robot Stacy. I also did a robotic arm that basically did all the hard math and would draw what you wanted on a sheet of paper. So that's just a little. So it basically led me to my project that I'm about to present. So what is my project? So the basic premise of my project is, if you flash something on a screen at someone, and you have this headset which reads their brainwaves, can we have a program that, after having knowledge of how someone would react to these before, can make an educated guess as to what someone saw? So, some of my expert advisors for this are Dr. Beck. He's a director of pediatric neurology research at Children's Hospital in Denver. And Steve Cyrus, my dad, who's been a developer for over 30 years in the business. And as my support advisors are Drew Kastner, who's been on my video game design team, Megan Hansen, who's also a TSA chapter advisor, as well as Alex Edwards. So my objectives was to study the brain with my own headset. So this is an EEG headset, and I bought this, and basically what it would do, it would take you a readout of your brainwaves to the screen. And one of my objectives was just to explore and kind of experiment and see what I could do to see what happened. Another objective was to research about the brain and learn how the brain functions. Another one of my objectives was to actually find the patterns that certain pictures, and originally I was going to go for, if I flashed a color on the screen, then could have predicted a color, but it kind of moved more to a pattern. So what you see here is actually a specific pattern for every time I would flash horizontal stripes on the screen. And you can see that this is voltage measured in microvolts, and this is a period of 1 second. So you can see down to the millisecond that there's peaks and voltages and falls, and this pattern is basically what identifies in your head what certain patterns that happen in your brainwaves when you view them on the screen. Another one of my objectives is actually a program that can, once it has all of these, it could go back and make a guess as to what you're looking at on the screen. So like I said before, once you flash something on the screen, you can take it and make it guess. So if you're flashing color red, it will come in and guess red. And so here's a little bit of here's a graph of actually my final product. So you can see I had 24 different pictures, and some of the pictures could be identified by my program easier than others. That's why some of them on the first guess could be 40% accuracy. So 40% of the time, I would flash whatever stimulus this was, the program would guess and say, okay, it's that stimulus. Okay, so it also wanted some working demo as a way to visualize the process. So what you see here is, so this is a picture of what was flashed, and my program came in, and with pictures and knowledge of all the different things that I flashed before in the program, it synthesized this image. You can see that it's mainly this image, but there's also portions of it are the other pictures I used in my project. But since the program analyzed it and found the major pattern for this guy in whatever brainwave that was at the time, and created this. Okay, so a bit about my logo, and really the title of the project. So the name of my project is Delta Animus, and Delta is a Greek letter that really used to mean a triangle, and it's used to signify a change in where, like there's like a change in heat or a change in velocity in these science terms. So naturally, there's a triangle to represent that. And animus, which is a Latin word for intellect, memory, or consciousness. So what my project is measuring is this change in your consciousness. And what this cutout is actually a cutout of a diagram of a brain from the human connective. So, time on my project. So basically from October to January, it was a very heavy research period. It was really how the brain works and what is a brainwave and how would you go about measuring brainwaves. So I researched a lot about EEG headsets. So what you can see here is the professional EEG headset. These are expensive machines that doctors use to study the brain. And typically there's about 32 electrodes and arranged in a 10-20 system. So what is EEG? What is EEG? So EEG is it's a really view of voltage over time, and what causes the voltage is, so neurons over here will communicate to some neurons over here, and when they communicate, they send like electrical impulse. And that electrical impulse, you see this electrical impulse is sent down the axon in an action potential, and then the EEG can pick up on this and sense this. So what you see here is a picture of one of my graphs that I got from my headset. You can see that there's actually, this is the voltage that it picked up, and you can think of this voltage in the same way as like a battery, except it's about 1 million times smaller than what a battery's power would be. So you can also think of EEG like an orchestra, in the fact that there's all these neurons playing, firing off electrical signals, and when they come together, they form this song or a symphony. And then the headset acts as like a microphone listening in on that. So this is the output of this orchestra of neurons. So what is no vogue potential? Vogue potential is a name for a change. It's a change in the pattern of your brainwaves brought on by the onset of the stimulus. So, for example, here there's a flash checkerboard pattern, and after that, you can see there's a sharp spike in your brainwaves, and that's really your brain's response to seeing the checkerboard. So, why is this an important concept to know? Well, it's important because for the purposes of my project, it was to be able to identify which pictures I was flashing, so you could do that and you could guess. So it's important to realize that the difference between these peaks for this region versus maybe these peaks. So, yeah. Alright, so the data you get from the headset is really noisy. You can think of this as like static on a television or static on a radio signal. And so you can see it's really jagged and bumpy. So then we use this equation called exponential smoothing. And then it goes in and it takes this noisy data and it transfers it to a smooth sort of EEG signal that it still keeps the overall trend of the data except without all the spikes in it, so we can go back and analyze it easier. So I also researched a lot lot of medical papers. So I would read through these medical papers, and most of the time I could only get to be just a quick summary of what they were, because you have to have you have to be at a university to actually even access these most of the time. So I would read these and try to get a general idea of what's going on, to familiarize myself with this field and science a little bit. And like I said, just for example, just to look at this one paper, it would cost $36. So February for April was really the time where I started developing my program more. I made this EEG data recorder, and I researched signal processing techniques. I found all the patterns in my data. I developed my pattern recognition algorithm, and I also learned this new programming language, MATLAB, which basically makes drawing all these graphs a lot easier than it would be on my own. So, the process of obtaining data. So, firstly, there's all these possible pictures. Now, I have like 24 possible pictures that are shown, and randomly one of these would be chosen and flashed at the screen. And then someone wearing the headset would be looking at the screen. First it would be black like this, and then suddenly it would be a stimulus flash for 1 second, and then it would go off. And in that time, it would get this EEG signal for 1 second right after. And then after that, it would take it and put it into this MySQL database. So this acts as like a program's memory of what was going on. So now that later you can go back and recognize the patterns and actually analyze and predict. So pattern finding. So after it gets placed into the database, it goes to my MATLAB program where it generates all these average potentials. So it would get. So let's say this was flashed. Okay. It goes in, and now it gets a list of all the times that was flashed, and then it will take the average of all of them, and it would derive this pattern, which is a unique pattern that's associated with this exact stimulus. So pattern recognition. So I used this. I was exploring MATLAB one day and I found that this equation, which in the simplest way to put it is, if you have two signals, it will tell you how similar they are, basically. So like the shape and size will play a factor into it. It's basically a way of looking at it. And so how did I use this? Well, let's say this is one of the recordings after I flashed. It would take this recording and compare it to all the possible pictures and their unique patterns. And then, so it would look like this. There's the recording. Here's the green is the pattern. And here's like a measure of how much it actually relates to it. It would use that, and it would rank it would take all the possible ones, and there's about 24 possible patterns it could be, and it ranks them. And after the one that's ranked the highest should, in theory, have the highest number here, and then that would be its guess. So now of the 24 possible pictures I used, you can see that each of bars corresponds to one picture, and this is the program's accuracy on its first guess to identify it. See, some of them had almost no accuracy whatsoever, but some of them, almost 40% of the time, they could. Just given, you could take this unknown thing and match it to whichever stimulus was flashed for that period. I also decided to plot all the times that would rank what was correct, and it would rank it in the top 3, because I figured that maybe later in the time, once you have the top 3, most likely you can narrow it down to more than a guess. So, on average, 33% of the time, it would rank the right stimulus in the top 3. And some of these were as high as 60% of the time. I know you may think that, okay, actually, I mentioned that for the first guess accuracy on average is about 15%. You may think that, okay, that's not a very high percentage. But the green line is actually scaled up times 10. But what we're measuring, this green line, when it's recorded, when you find these averages, it's within a range of about plus or minus 3 millionths of a volt. It's such a small change that you have to find in this bigger mix of things. Because there's a lot of things happening in your brain at one time. The point is, can you find this pattern somewhere in the mix of the brainwaves? Okay, so once it has all the rankings, once it has ranked all the possible pictures, it will take the top 3, and it will, so if this is what was flashed, if it guessed correct, it will take the top 3 and try to synthesize a guess by taking one. So once it has compared them all, it will take the top 3 values, and using those, it gets a percent likelihood of how likely it is to be. Let's say it ranked, if this was what was flashed on the screen, it would then compare all the 24 possible stimuluses and say this one's ranked the highest, this one's ranked second, this one's ranked third, all the way down to 24 easily. And so then we take these top 3, and then based on their correlation values before, it would try to synthesize an image by combining all of them. You see, the more likely it was, the more is taken into account for the final combination. You see, so here's some other examples of it happening. So here's what was flashed, here's a synthesized guess. Another synthesis. You can see that there's also a vague shadow in the other possible pictures. And here's one that didn't work as well. You can see that you can still see the checkerboard pattern in there, but you can also see there's also equal images on the images, so you can see that that's actually taken into account as well. Alright, so that's basically the output of my project. Here's my video. I'd like to thank Dr. Beck for helping me with a lot of the hard neuroscience concepts. I'd like to thank my dad for helping me with the auto programming and database aspects of my project. My mom for support, also all my wonderful support advisors, and Danny for helping me Photoshop things. And I'd just like to thank my lab rats who actually got all this data. My brother, Shayla, Caroline, and myself. So, any questions? Probably because you have an idea because this is really measuring one plane on your head. So there could be like different. It's just another thing you compare it against. So yes, probably most likely. Oh, yes. The question was if I had like a better headset, could I get a better accuracy? Well, and the answer is yes, because I have a better idea of what was going on in the other parts of the room, so it was just another thing there against. And all of the things about the nicer headset, there are a lot of perks with it. My headset is $80, and you can They can be upwards of about $8,000. Even, so, next question. So the question was how many sensors did it have? It had 1 point it was 1 point on the forehead, that's it. So yeah, I mean, I still got it to like something with 40% accuracy. Okay. Excuse me. Where do I want it to go? Well, next year for senior projects, I wanted to do I want to expand on all my background with robots, so they will make a robot that can see the cameras better. So I want to use apply my research and have a robot that educates the way people react to pictures. So that's what I was trying to